endothermic, which depends upon what kind of substances are there in water. We know that exothermic means the amount of gases, the temperature is being released to the reaction environment. Endothermic means the amount of heat energy will be absorbed during the reaction zone. And based on that, how much quantity of things will be evolved or absorbed will be understood. And whatever the gases are removed, I have told you. And whatever the gases are absorbed, the amount of oxygen will be absorbed inside from the air. When the oxygen is increased in water, and some of the organic matter, when it is being degraded into smaller form, will be oxidized into carbon dioxide also. Again, the carbon dioxide concentration will be increased. This is the problem of aeration. But when the net calculation gives conversion of degraded organic matter into carbon dioxide and the removal of percentage of organic matter removal, when they compare, the carbon dioxide organic matter removal is more. Already the water contains a very smallest component of organic matter, then the carbon dioxide concentration will be increased. So the efficiency of organic matter aeration process, again, it depends upon the type of water what you are treating and the degree of treatment what you are requiring. Either if it is from the wastewater from sewage or from industries means you have to reduce the organic load. So you can do whatever you want. Suppose the water is from the groundwater which contain lot of dissolved gases and it contain organic matter, but it may contain very less. Then there is the advantage is something different. So the aeration is in general, you have to supply oxygen into the thin sheet of water and you have to provide more surface area water to the air to interact. And there will be the formation of air-water interface will be very important. Based on that only the efficiency of aeration treatment will be decided. Clear? And the another thing is, different types of aerators are available. Stepwise or cascade type and packed bed column which provides the counter current flow and a diffused aerator that you have to provide the perforated trays or wire mesh to diffuse the air, and these are all the different types of aerator. And the theory of aeration is there. What is the theory of aeration? In aeration, what are the factors which are all affecting the aeration process? And one more thing now itself I tell, when you are talking about this water treatment process, from the water treatment, every process they will ask about the theory. Almost what are the theory, what are the concepts, and what are the types, and at last, what are the types of particular unit, what are the limitation and what are the advantages. From each process, either they may ask anyone. From one process, they may ask theory, in another process, they may ask what are the types, in another process, what are the limitation, and about another process, they may ask what are the advantages. So you have to study all the things. Based on that, they may ask the questions. And I will, any other thing, something more you want? And this aeration process is effective to remove all the organic matter. But whenever the gases which are all dissolved, which is non-volatile in nature, that cannot be removed by this aeration process. That is the important limitation of aeration process. And moreover, another thing is the important thing, elements which are on water is iron and manganese. That is Fe2 plus and also Mn plus. These two ions will be there in water. These ions are giving taste as well as color to the water. This could be effectively removed by this aeration process. Otherwise, the color of the water will be affected. And this much only I could remember now. Anything else? Hello?
Ma'am, types, waterfall aerators, spray aerators. Brief.
Yeah, those are all type. No, you can read and if you don't know and not understand the function, you ask me, I will explain it anything.
Okay,
Even
ma'am.
after class over also you can ask me, I will explain. I won't deny. Clear?
Okay, ma'am. Okay, thank you, ma'am.
Okay, fine. So now we'll enter into the filtration process. Okay, now it's supposed to be the interaction class, then it will be good. So what idea you have about the filtration process? What is filtration? I thought I complete this block today. Whether I can or not, I don't know. Let me go a little fast. So you come fast, what is filtration? Have you seen any filtration unit? Hey, what you are all from this,
Filtration is the process of removing unwanted material, ma'am. From water.
Okay. Then little fast. Different people may have different opinion. What is that overall? We'll see. Yes, that is correct only, ma'am. It is not wrong. Then.
Okay.
Then. Many people are not there. Why we have to do this filtration process in water treatment?
To purify the water.
Okay.
To separate the solids, microorganisms,
Okay.
micromolecules, liquids,
Okay.
gases.
Then. Okay, filtration is what? Filtration is a mechanical process or electrical process, or it is a physical process?
It's a mechanical process.
Mechanical process. Then, any other explanation? Yes,
I think
please.
it's both, ma'am. Mechanical and chemical.
Mechanical and chemical. Okay, then. Yes. Okay. I'll tell you why we have to do this filtration process. Why we have to do this filtration process. And every day we are doing filtration or not at home. Have you seen any filtration unit at home? Yes?
Purifier.
No? You are doing tea, na? You are making tea every day, correct?
Yes, ma'am. Yes, ma'am. Supposed to say
What
that.
is happening exactly? What is happening exactly when you are filtering the tea? What is happening?
It's a physical process.
It's a physical process. Excellent. What is the difference between physical process and mechanical process? Small difference is there. Anyone can please little fast. I am allowing you to think. Then you can remember that.
Mechanical process is done through machines, ma'am.
Very good. Physical means? Physical means?
Physical is
human by human process.
Okay. Yes. Then. Yeah. Is actually filtration means you can do filtration through anything. And you, if you want to remove something from other thing, which will be differed from the nature or size or density, you can follow this filtration process. Now, tea filtration, what you are doing, you are separating solids from water, correct? Liquid, not water, liquid. You have the mixture. The mixture contains solid and liquid. Those liquid, you already have the liquid. That liquid has solid. You wanted to separate out the solid from the liquid, so you are doing the filtration during the tea making. Now, what is you are not following any other concept over. You have not applied any density concept, or you have not applied any pressure concept, or no other media, nothing. You have only perforated wire mesh, or you can say simply wire mesh you have used. Through that, you just make a flow, and that flow which restrict only liquid to allow and the solid to stay back. That is the process happening in the tea making, which is nothing but simply filtration. But when you do the filtration continuously, your tea gelada will allow you to do tea making continuously. There is a limit. Beyond
No,
the
madam.
limit, you cannot do. Clear? Because which there the play of volume come into the picture.
Yes.
Operation will be closed, is it? Yes or no? I am technically teaching. You can remember this example when you are writing exam also. Now your tea gelada is completely filled up. Now what happened? Filled up means what does it mean?
No porous will be
Volume.
allowed to go the flow of liquid. Yeah.
Yeah, which makes the overflow of liquid. What does it mean exactly? Whatever the perforation is there or wire mesh is there, all the
Flow.
hole is already blocked, correct? If some other
Yes, ma'am.
so few holes are open means then it allows to penetrate
Slow.
the liquid, right?
Slow
That does not,
process.
yes,
Yeah.
that does not happen means it already blocked the holes. So when it
Yes, ma'am.
blocked the holes, the system started overflow. That is
Yes.
called back pressure in filtration system.
What, ma'am?
Back pressure.
Yes, ma'am. Okay.
Okay. Or you can say that is called pressure drop. Why it is called pressure drop? Pouring the liquid is supposed to go, but it is not
No
allowing
outlet.
to
No
go.
outlet.
Yeah, no
No
outlet.
outlet.
Inside the perforation or inside here, inside the perforation, over the volume, the liquid does not permit to flow, which
To overflow.
builds the pressure. When it builds up the pressure, then when the pressure
Start overflow.
increase the limit, then it started overflows. The
Ma'am, then
same
what is
thing.
the difference? Sorry to interrupt, ma'am.
In
Ma'am, what is
ma'am,
the difference between the filtration and straining?
straining. Straining is the part of the process of filtration, ma'am.
Okay.
Okay, it is a part of the process, which is important fact. Strain means you are straining out. There will not be any interaction between solid and liquid.
Okay,
You
ma'am.
understood?
Yeah, ma'am.
Okay, it's simply whatever something is there, you are give the pressure and remove. That is straining. But filtration is not like that. Filtration means what exactly? It is not a mechanical process. 100% it is not at all a mechanical process. Please remove from your mind that filtration is a mechanical process means. It is not at all a mechanical process. Clear? It is a kind of physical process because sometimes it is working under the pressure, sometimes it is not working under the pressure, sometimes it is working based on the gravity, and somewhere something is being induced and overlocked, and void is a matter and density is a matter. So what altogether people are telling, it could be the physical process and not exactly only physical process. It could be the physical process. Clear? So what is exactly? Because in filtration process, straining is happening. What is meant by straining? Because we are filtering or we are separating the solid particles from the liquid, the particles may not be equal in size. There may be different size of particles will be there. But when you are having the strainer in the sense, whatever the perforation or perforated wire mesh or tea gelada, whatever you have, that will be uniform in size. Are you agree? If you want to
Yes,
see
ma'am.
where tea strainer, that is uniform size. But all the solid particles 100% not uniform size. So whenever the particle size are larger than your perforation size, that time if whatever the hole is there in the strainer will be blocked.
So
And
what
when
about
it
the
is
lower side than the mesh? Then what is it called, ma'am? It's a lower than the size of that mesh.
it is the smaller size particle, no other definition we can give, no. Then you can make a filter in such a way. For that only people have introduced different types of filters.
Sizes, yes, ma'am.
Okay,
Right.
you have the T
Hmm.
filter. The T filter is designed based on the what is the particle size of powder is in the market.
Yes, clear. Clear, madam. Okay.
Yeah, based on the
Yes.
market product characteristics only, they are making the T filter. In that, many
Mm.
types are there. Whatever things are selling out on the road, it may have the bigger size. I am not responsible for that. I am talking about the standard items.
Yeah,
Okay.
ma'am. Okay. Okay, ma'am.
So when it is happening like that, then filter media is completely blocked. And the larger things, why we are doing the filtration process after flagellation and coagulation, whatever the residues are coming along with the water, we have to remove from the filtration process. That is the purpose of studying of this unit. What is the filtration process? Where the filters are being introduced in the water treatment after sedimentation with coagulation and flagellation. What is happening there? All the smaller particles are separated out from the water by coagulation and flagellation, and the separation is done by physically through the clarification process. Even then, from the clarification, 100% removal is not at all possible. To reduce the load of filtration unit only, they have introduced a clarifier in the middle. Then the clear supernatant is taking that clear water only, they are injecting into the filter. In the filter, whatever the particles left over or mixed with the clear water supposed to be removed. So here the effective removal of coarse particle, not only from the fine colloidal or any other thing. When you are adding the colloidal particle into the wastewater, this colloidal particle will aggregate microorganisms also which are there in the water. So those things will be very small things. This microorganism along with the organic or inorganic substances sometimes will be blocked, and this the blocked things will be additional mechanism for this removal of filter or sedimented particles from the treated water from sedimentation process. Now again I'll tell, we are introducing the filtration process for removal of some of the colloidal particles. The colloidal particles may have organic and inorganic substances along with pathogens. We cannot narrow it. It contains only organic, only inorganic, or only pathogen. All things will be there. All things will be aggregate with one another, and the particle size would have been increased. Those two things could be removed from the clarifier. In that also, some of the things will be very smaller particle will be in suspension form in the water that we cannot see by our naked eye. Those things we have to be removed. So what we are introducing the filtration technique after coagulation and flagellation. What is happening here? When the particle size are higher than the pore size, then they are physically blocked in the unit. So this whenever the unit is blocked, that is called straining mechanism.
Overflow.
Straining
Training or
mechanism.
what?
That's what you people are coming places technically. Those who are talking very good language, they won't say T filter, they will say T strainer. Those who are following the good language, they will not say T filter, they will say T strainer, because that strainer, what it does, it removes the bigger particle which are all bigger than the pore size. Those things will be blocked or clogged in the filter media. That's what they are called strainer. So strainer is a process, and it is a part of the process which involved in the filtration process. Is it clear, ma'am? What is the strainer? Somebody asked me.
Yeah.
Okay.
Yes, ma'am. Got it, ma'am.
Okay, thank you, ma'am. Okay, now we'll talk about the filtration process. Okay, why we have to do the filtration? That I told you already. We need to remove those things which are all from the water, that may be any things, anything organic or inorganic or any microorganism, everything we have to remove. At last, when we wanted to commit that water for human consumption, it's supposed to be free from the turbidity. What is meant by turbidity? Little fast.
Turbidity is the color, the particles that give color to the water.
No, ma'am. That is color. Now, physical parameters or physical characters. When we are saying in terms of four. That is color, turbidity, odor, and temperature. These four parameters are called physical parameters of water characteristics. So turbidity is different from color. That is, turbid means what? Turbid. Turbid means whatever the particles are there in suspension in water, those are all called turbid. Turbidity. Some unwanted particles are suspension or floatable in nature in water. That is called turbidity. It is not. It is.
So
We can say
means this
that.
is not.
Yeah, I will say very clearly means which reduce the transparency of water. The substances which reduce the transparency of water is
Hardness?
called
Is
turbidity.
it called hardness, madam? It is called hardness.
Yes, sir.
Is it called
What do you
hardness
mean?
of water? It will be
I
also
can't
called as a
hear you.
hardness, madam.
What is called water?
It is also called a hardness of water. No.
No. Hardness is completely dissolved. No.
Okay, ma'am.
About the hardness and all I spoke in the last class. Hardness means what? The solid is supposed to be completely dissolved in water. Carbonate and bicarbonate of calcium and magnesium salts. That means what? Calcium carbonate, calcium bicarbonate, magnesium carbonate, and magnesium bicarbonate. All the four compounds are completely soluble in nature. And also chloride and sulfate of calcium and magnesium also completely soluble in water. That when it dissolved in water, you cannot say hardness in that water. After drinking or after using only, you can understand that the water is hard or the hardness of water is there like that. But I am talking about the turbidity. Turbid means which reduces the transparency of water by presence of some of the floatable or suspendable materials. That is called turbidity.
Okay,
Clear?
ma'am. Clear.
Yeah, if
Yeah,
you
ma'am.
have doubts, you can do some of the very clearly. If I say you take talcum powder, no? You take some talcum powder, you put it in water and stir it. You can find out. Or another way I will tell you, you buy the crystal salt from outside, not from the packet. Open crystal salt you buy, there will be a small dust particle will be there. You put it in the water and dissolve it properly. Salt will be dissolved and the dust particle will be suspension in water. That is called a turbid. And for easy understanding in the exam also you can write the same thing. The substances which present in water which reduces the transparency of water is called a turbid. The turbidity will be measured by NTU, normal turbidity unit, like that. So why we have to do this filtration process? The filtration process which reduces the turbidity and also suspended particle concentration. As I told you already, the water is good or bad, how we'll see by physical look with the physical appearance. Suppose I provide the water in 3 glasses. In one glass, little turbid is there. In another glass, clear water is there. But the taste is not good. And another glass, some colorful water is there. But no one should touch that glass of water. By look itself, you should say which glass of water is good. What do you do?
Second one.
You will
Second
select
one.
the water, clear water, which is
Second one.
yeah, but transparency in water. The remaining two are look-wise not good because one is turbid and another one is colorful. Even then, if you know that or if you don't know that the water quality is good, but we will not select that water, correct? Because that's
Yes.
what for anything the physical appearance is very important. Like that, when we are doing this filtration process, the water supposed to be you want to make the water supposed to be free from turbid and suspended matter, then you have to do the filtration process which reduces this turbidity and suspended particle concentration to some level. And nowadays very recent in 20th and middle of 19th century to now, the filtration medium can reduce the turbidity level less than 1 NTU. That means it is very good water, it seems. And also, whatever the infected material, whatever the coagulation and flagellation substances will comes from different parts, and everything will be reduced to some extent or completely from this filtration process. That's what nowadays we are using this RO system. What RO system is doing? Anyone can tell, please? What RO system is doing?
Reverse osmosis.
Reverse of
This name of the system is reverse osmosis. What does it work? How does it work? What is happening exactly? Little fast.
Osmosis means movement of water from higher concentration to lower concentration water. Reverse of it is moving from lower concentration to higher concentration through semi-permeable membrane.
Very good. Somebody is telling exactly. Very good. Excellent. That's all. So now they are doing reverse osmosis. Whatever the soluble salts are there in water, whatever soluble. I'm not saying that only insoluble salts, soluble and insoluble salts, whatever it may be there in water, that is removed from low concentration, high concentration through the semi-permeable membrane. The membrane is having the pore size of less than nanometer level. Then it is being separated. The problem with that is whatever the wanted or required nutrients are also removed from the filter. So what we are nowadays people are having all sort of bone and teeth problem. This RO unit is removing all salts, essential salts also. Why we are doing that? Because the water is having some turbidity and suspended matter means that people are not accepting. It is good for health or bad for health, it is secondary point. It is not, people are not accepting that, so they wanted to remove it. When you are removing all essential salts, automatically the taste of the water will be increased. So is it good or bad?
Bad
Is
man.
it bad? That bad water only we are drinking from the water filter. And nowadays, these marketing people are very clever. What they are doing now? After this, so you people are telling that all minerals are removed. So after there will be a two direction in RO system. One is good water will enter into the water filter. Another one is some name is there. I forgot. Technical term is there. Another rejected water will go down. That rejected water they are entering into the water filter to maintain the mineral level. They are telling that may contain pathogens also, correct? Isn't it? That may contain some pathogens also, is it? My voice is audible?
Yes, ma'am. Yes, ma'am.
Yes, ma'am. Yes.
Then like that they are doing that. So the same thing here, what they are doing in the water treatment process, it is not something like a reverse osmosis. They are using the physical process through the filtration media. This filtration media reduced the turbidity level less than 1 NTU, and also which reduces the suspended particle up to the acceptable level. When we are consuming such a water, there will not be any problem of bone and teeth. So still I am requesting you all, I am doing that. Use the municipal water and boiled water, no health issue will come. Especially for Hyderabad, by grace of God, we are getting very good water. The physical characteristics and the hardness of water is exactly up to the limit. They are not doing any process treatment for removal of hardness or something like that. Suspended water. TDS, you would have heard the term TDS, total dissolved substances, and also hardness, everything within the limit. For that, they are not doing any process. Only the problem somewhere, sometime the pH will go down, come, and this pathogenic bacteria will go on, come. During the rainy season, the color will come, go down. For that only, they are giving the major treatment. So, by goodness, our goodness, we are getting the good water. You can use that water and boil it and drink it. It is more than enough to maintain the health. Beyond that, your wish.
Ma'am, we are drinking mineral water nowadays.
Mineralized water or mineral water?
Mineral water which we get from for daily use, we are drinking mineral water. Does it exactly contains mineral water or just for namesake?
Yes, sir. That's what I'm telling. better you can drink the municipal water and boil it and drink it. No issue. But you have to boil. Still it boils, you have to boil. That
Okay.
will be better. That will be good. Why are you wasting the money? Instead of that, you can put the money for this boiling, either electrical or this LPG or CPG, anything. Only little bill will come, but the health benefit is more. I am doing that only. Not many years, for 3 years, I am following that technique only. I don't have any issue at all. Okay, then what is the use of this filtration process, which removes all the pathogens? Because as I told you, from the coagulation, flagellation, and the sedimentation process, there will be a considerable removal of all microbes. But some of the microbes, some of the bacteria, viruses, and some of the protozoa, those things cannot be removed by chlorination process or disinfection process. And if it is there also, what is happening? Those microorganisms highly resistant to the chlorine. So how to remove those things? Some protozoa, it is highly dangerous. You know that any stomach related problems are coming means first the people will check that protozoa and parasite test only. So those protozoa, why we are doing disinfection process? To make all pathogens to be inactive, we are doing that disinfection or chlorination process. But this protozoa, particular type of protozoa like cryptozoidium and giardiaceae, those protozoas are highly resistant to this chlorination process. When it is happening like that, how we can remove those things? If it is there in water, because it is resistant to water, we cannot remove like that, means the water cannot be used for human consumption. In such a situation, what we do? What we have to do? Remove those dangerous protozoa. What we have to do? So what they are telling, you cannot do through this chlorination or disinfection process, but it can be removed by some of the physical process called filtration process. What is happening exactly? And when you are following this slow sand filter, there are two different types of filters. Infiltration process, generally what people are using for water treatment. One is slow sand filter, another one is rapid sand filter. Based on the quantity of filtration, that means filtration rate, it is being classified. The fast and huge amount of water can be filtered, means that is rapid sand filter. Slow filtration rate and the surface area is very less, means that is slow sand filter. In both the media, sand is the supporting media. And many things are not there in the book, and you are studying the new book, and whatever the essential parameters supposed to add or understand in the subject is not there. Because when you are talking about the filtration, you should know what are the types of filters and what are the media of filters. They have told it is slow sand filter and the rapid sand filter. Sand alone will not be there. Sand will be there. Along with the sand, many supporting packing material will be there. How you have to use the sand? What sand you can be? All the sand cannot be used. You have to select and collect the sand from the which contain lot of quartz, around 90 to 98 percentage, 92 to 98 percentage of quartz content in there. Whatever the sand is having, that kind of sand you have to select. And in that sand, it's supposed to be, all the sand is not in equal shape and equal size, correct? Have you seen the sand in riverbed and also in seashore? How that sand is looking? Any one of you can please?
It is smooth and fine.
Huh?
Smooth.
You people please talk a little loudly. Yes, tell me.
It is very smooth and fine, very fine.
Very fine. Have you seen any sand in riverbed?
You very fine sand, mist sand, fine sand.
Oh yes, that's what the people are using for construction purpose, correct? Otherwise,
Yes.
that cannot be used. They say when the whatever the sand they are getting from the riverbed or river basin or coastal area, they are using that sand directly for construction, or what they are doing?
It's a weathered sand. It is a eroded and weathered sand.
So river sand is used for construction, ma'am. Godavari sand and everything they are pulling for construction nowadays.
Okay, they use it directly, or they are
No,
doing
no, they
sieving?
filter. No.
They will sieve and then use.
They do some sieving for the size reduction, correct?
Yes.
Yes, ma'am.
Yeah, when they do the size reduction, whatever the rejected materials are there, have you seen? Those are all looking like a small pebbles. We can
Stones.
say these stones,
Yes,
they are,
granular type pebbles. Yeah.
yes, sir. That is
Yes, ma'am.
different size, and also the shape will be different. Those
Yes, ma'am.
sand containing large quantity of quartz. That kind of sand they have selected for making this sand bed. And simply they cannot use it along with many supporting porous material they are using, anthracite, bituminous, subbituminous, some of the nut shells, and all together they are mixing. And based on that, they have named that filter dual media and multimedia. And initially, whatever the filter medium people have selected, that selection filter media, they have used only two layers. At the top, they have provided the sand layer, and the bottom, they have provided the porous layer. What is the use of it? Top layer sand means it is completely compacted, and the bottom layer is highly porous means it's little loose packing. So at the top you have packed everything tightly. At the bottom layer it is loose means then the filtration efficiency is not high, and also they cannot meet the demand of water how much they have required. And what they have done later on, they make the ulta of it. At the top layer they make a porous, and the bottom they have make the compact strong soil media or sand media. This is also called dual media. Through the dual media they have achieved some good result, and they have their filtration efficiency is high, filtration quality is high, and also the filtration media is coming for quite a long time. And overall, when they wanted to meet the pharmacy character quality of water, then after they have introduced the multimedia filters. In multimedia filter, they have achieved with the 5 different layers of filter media. In that, sand material is there, anthracite is there, bituminous is there, apricot is there, like that different porous material they have used, and they make it as they have packed it as a column with high pressure, and they have used as a filter. And one more important things about this filter unit is how you can recover this filter media. Once you use the filter, and we can reject it or we can reuse this filter media.
We can use it. We can reuse it
How to use it?
by backwashing with waters and all.
Very good, very good. Excellent. Yes. So we can, this filter media is whatever the filter media people are selecting, that's supposed to be highly inert in nature, and also with a high stable material, and a highly porous in material. These are all the important parameters to be considered before you select as a filter media. So don't think of your tea gelada. Tea gelada should be steel or plastic. If you make it in iron, will it be good? It will be corroded, correct? Within 1 week, it will be corroded. Then you have to use it and throw, because the corroded material will be coming along with that your filtrate. Then if you drink or eat something through that, with that it will not be good for health. So they are selecting the material for perforation. Either it's supposed to be highly inert or not reactive, and it is porous in nature and highly stable for quite a long time. That's what nowadays, if you look at very high quality filter or strainer, those strainers are either in SS very strong SS material, or they are using a polymer like plastic material. It is not plastic, it is polymer material that only they are using. Both can be highly stable and highly non-reactive, and which will not be reactive with many things, and highly porous in nature, like that substance they are selecting. And if you want to wash that, you are pouring, don't wash the tea gelada directly. You always, your tea strainer wash from the back side. Like that concept here also, you can use any sort of filter media, and you can use that filter media continuously. When you are using the filter media, there will be a pit formation based on the pressure and the load of the pollutant. And you can recover the filter media by backwash, and you take out the material, you dry out the material, crushing and mixing. Again, you can refill into the filter unit, and you can use it continuously. That is only the advantage of using of this sand filters in high quantity or high demand water treatment processes. Now, this filters are highly useful to remove this highly active pathogens. The pathogens which are highly resistant to the chlorination process could be removed through this filtration process. And especially in slow sand filters means I told you that the rate of filtration is very less and the surface area of filtration process is very less. There they are removing high removal of this highly active protozoa from the filtration process. Clear? So what? The first one, what I have told you, which was removing the turbidity and the suspended particles. And the second I told you, which is highly removing the pathogens. And the third one is, it is enhancement in disinfection process, because whatever the resistant microorganism like protozoa and other pathogens, they are removing from the filtration process. So what the further treatment from the filtration process is chlorination, and the load of the pollutant will be reduced from the filtration. So what it will be increasing the efficiency of disinfection process. And some of the this is very important what I am going to tell. Some of the suspended particles which are all in the water, which can shield the pathogen, and this will be reducing the reaction of fluorine with that pathogen, and set chlorine or any other oxidation treatment and ultraviolet radiation. So removal of this will be very difficult during the chlorination process. That will be removed by this filtration process. That is another advantage of this. You know that this ozone and ultraviolet lights and all people are using for water treatment. Hello. I'm going fast.
No, ma'am, we don't.
No, ma'am. Every time we have to switch on the microphone. That's why we are not saying yes or no so fast.
Okay. Because I don't know who is linking and what flow I am going. And that is
No, ma'am. You're going fine, ma'am, and we are also listening.
okay. The thing is, all oxidative substance we can be used for water treatment to kill the pathogens. Okay. Ozone is one of the important oxidant which could be used for water treatment, and not only chlorine. And there are different types of disinfectants are there. And many halogen, chlorine, bromine, iodine, fluorine, all are disinfectant only. And some of the active, yes.
Ma'am, ozone at tropospheric level is a greenhouse gas and a pollutant. How can we use it further?
My God. Okay, shall we continue the discuss in this class or in the next class? Anyhow, second half I am going to take the air pollution control. Okay, I will tell now. Ozone. Ozone is a pollutant or not? Ozone is a pollutant or not?
When it is at troposphere is a pollutant, when it is stratosphere, it is a good.
No, ma'am.
Yes.
Ozone can be found in the atmosphere also. When oxygen molecules again combines with another oxygen atom, ozone is formed. So it is there in a form of pollutant in the atmosphere.
Okay. All your answers are correct. Okay, I'll make that, sir. What sir said, I'll explain one by one. You please listen me. This is very important when you are studying this course. Okay. First of all, there is no ozone pollutant at all. There was no ozone pollution at all on the Earth's surface or in troposphere. Actually, ozone is a very good friend of us, or it is a very good company of us, or it is a well-wisher of us when it is in stratosphere, which is behaving like a blanket, which filtrate the harmful ultraviolet radiation from the sun, and which allows to pass only visible and infrared radiation, which does not create any health effect to any living things and non-living things on the Earth's surface. So the ozone is not at all a pollutant when it is originally originated. And we are all the culprit. Always we are damaging and spoiling our environment. When the human beings started making this ozone at Earth atmosphere, and the cost of manufacturing of ozone is less, and the stability is more, yes, more, and it is not highly reactive. These are all positive attitude about the ozone. So we can use that the ozone as a chillant or coolant or refrigerant. So what we are manufacturing in earth atmosphere for our own luxury life. If we make it like that, no issue at all. When it is released here and there to some extent, because of its oxidative in nature, which can be oxidized anything like human tissues also, which because of its highly oxidative nature, which can kill any pathogenic any organism, not only pathogenic, useful and harmful microorganism, everything it will kill. Even it will kill the human cells also. When we are making, when we made it, when we released it, this is one aspect. And another aspect is whenever when this air pollution is started increasing after industrialization, and we can say generally industrial revolution and civilization introduction. What is the impact of this industrial revolution and civilization? We have introduced many vehicles, and almost now, believe it, after 21st century, we have introduced many electrical vehicles. How that electricity we are getting? It is coming from air. Again, it is depending upon the power station. There we are burning all fossil fuels. What is industrialization? Industries are there. We are making many products. We are having the luxury life by using different clothes, all beautiful electronic items at home and non-electrical items at home. Everything we made it from the industry. The industry is depending upon energy. The energy is required from produced from the fossil fuel burning. When you are burning the fossil fuel, it releases all pollutant. That is simply, somebody said, anthropogenic activities. One among the anthropogenic activities is industrial evolution and also automobile sector. Automobile sector, what is happening? Any sort of vehicle you use, petrol, diesel, whatever it may be, or electricity if you use, electricity is from the power station. There they are burning the fossil fuel like coal, oil, natural gas, anything. When you are burning the fossil fuels, when the temperature is in more than 700 degrees centigrade, then it starts to release oxides of nitrogen not from the fuel plus air. What is air composition? Air composition is 78% of nitrogen. N2, it is stable component, and 21% of oxygen. The remaining are all inert gases, or you can say noble gases. That 78% of nitrogen from the air react with the fuel. It will not be reacting casually. Whenever the temperature increases more than 700 degrees centigrade only, that nitrogen is being converted into their respective oxides. The oxides are 5 different forms: NO, N2O, NO2, N2O3, N2O5, 5 forms. That's what they collectively say in air pollution, NOx. NOx means all these 5 components, indicates all the 5 components of nitrogen oxides. This oxides of nitrogen, 700 degrees centigrade, whenever it reaches, it releases to the atmosphere. Then which undergo some of NO, whenever it releases to the atmosphere, which oxidized into NO2. When the NO2, whenever it is in atmosphere, if any solar radiation is coming at bright sunlight, whenever bright sunlight is there, the NO is being break down into NO plus O. And that O, atomic oxygen combined with the atmospheric oxygen molecule O2, then it produces O3, ozone. Along with that, huge amount of energy is released. That energy is supposed to be absorbed by the air molecule, which is nothing but oxygen and nitrogen. Otherwise, what will happen? This oxygen atom and ozone molecule, it is irreversibly forming, destroying, it keeps on going on. Then at the end, ozone will be accumulated. Whenever the situation is happening because of activity of human being, and whenever the ozone form, that is the poison. Clear? So when you make it purposely and you are doing some treatment, or when it is existing in the stratosphere, which is protecting from the ultraviolet radiation, this is not the problematic product. Of course, which helps our life to protect from ultraviolet radiation. Nowadays, people are saying that ozone hole is formed. Yes, because of that ozone hole formation, some very little ultraviolet A, B, C coming or entering into the atmosphere. That's what now throughout the world is having many cancer, many eye problem, many plant affected, many plant related diseases are coming. This will be even no one can able to predict also. That is the issue. But that ozone has good oxidative property. That oxidative property, because of this oxidative property, which can kill any pathogens, any microorganism. So that will be useful for treating this water also. Is it clear?
Yes, ma'am, clear.
Clear? And also some of the, one more chemical I said, ozone, few more is there. Potassium permanganate, it is very less oxidative. They are not using it as a water. And ultraviolet light, chlorine and chlorine dioxide is very common disinfectant chemical everywhere people are using. The next lesson I am going to talk about only chlorination. I will teach very clearly about chlorination, don't worry. And one more is ultraviolet light. Ultraviolet light also people are using for killing this microorganism. You know what is the role of ultraviolet light? In some of the water filter, people are writing no RO plus UV plus UF ultrafiltration plus UV light plus and added copper something they are writing everywhere. Have you observed any in any water filter like that? Ultraviolet radiation, this also do the play like ozone. Ultraviolet radiation when you pass into the water, not only into the water, anyway. Actually, how this, any one of you from biology and biotechnology background in this class? Hello? Any one of you is from biology or microbiology or biotechnology background?
Yes,
No?
ma'am.
Okay. Yes, ma'am. Then how do you use this ultraviolet laminar hood, ma'am? Why you are using, how you are using? Please give small information to every one of us.
I have no idea, ma'am. I've done it long back. I am now into computer field.
I'll tell. Actually, when the people are doing microbiology or biotechnology or cell biology or medical biology work, it's supposed to be free from all pathogens. So what they are doing, simply I will tell for your own understanding, we are all knowing that biotechnology development, how is it? Hybridization process, you know. That's what we are having many variety of tomato, many variety of brinjal, many variety of bendi. In all, even flowers also many variety. Roses and all, n number of colors we are seeing how they have developed through this hybridization process only. When they want to do the hybridization, one cell, for your understanding, I am telling it is not exactly. One cell from one particular item, variety, and another cell from another particular variety, they will combine, they make one particular variety, third variety. This is called hybridization. When they are doing such a process, in air, million and billion, trillions of microorganisms is there. Microorganisms are there. Those things may affect or contaminate the original process, what they concentrate to do. So what they are doing such a things in a completely sterilized world. Completely sterilized world means where the place, in that particular place, there will not be any sort of microorganism. For that, technically, they have developed the unit. That unit is called laminar flow hood. There will be a light that is called ultraviolet light. That light, when they switch on, inside that flow hood means it is a container. inside the hood, there will not be any, they will switch on for 10 minutes, 15 minutes, 20 minutes, based on the intensity of light, it will kill the microorganism inside the unit. And whatever the process they want to do, they will already sterilize it and keep it ready. Inside the unit, whatever the process they want to do, they do it, including the blood transmission and fertilization. Many things we people are doing nowadays. Now, all things, small process. Even if you want to find out what is the pathogenic bacteria in the sewage water, including this, our fertilization, all process people are initially doing in laminar flow hood only for protecting the infection from other things, from air or water, anything, or human. Now we are saying I am very clean and pure. If you take your look at your eyes through the microbes, then you can understand how many millions and billions of microbes are there. That is true. We cannot avoid it because we are all human beings living in India. So, what is that? The ultraviolet radiation, which have the capability to kill any microorganism. So in water treatment, people are using this ultraviolet radiation for killing of pathogens. Why? Whenever these suspended particles will be covered, when we are doing the chlorination process, it will be shielded in, then that could be reduced by this filtration process. Even not only chlorination, any ozonation, ultraviolet light introduction, anything which cannot be done for that much costlier process will be done by this filtration process. So that is the advantage of this filtration process. Clear? And the support of chemical treatment, as I told you, all these things, when you are doing this coagulation, coagulation, and the water is hard, then you have to do the softening process. And whatever the salts and whatever the particles are, whatever the chemicals are produced from each stage of process could be removed by this filtration process. And when we wanted to do some other odor and color and taste treatment through the activated carbon or some activated carbon means what? Anyone can tell please? Little faster. These are all things you must know. What is meant by activated carbon? Activated carbon means what? I am telling you. Okay, activated carbon means nowadays you have the electrical backup filtration system. Earlier days, the water filter system was there. 2 cylinder will be there. Bottom one cylinder and top one cylinder. The top cylinder, 2 white color column will be there. Have you seen? Any one of you could see? Hello.
Yes, ma'am.
Have you seen that old water filter system?
Yes, ma'am.
How it looks, ma'am?
It has candles, white candles, and
Candles will be there, and 2 cylinder will be there, correct?
yes.
Okay. Now that 2 white color column is not outside. They would have given some sort of calcium carbonate coating, but inside that white color, there will be a column called activated carbon, which is nothing but carbon. The carbon means they produced in such a
Voice is
way.
interrupting, madam.
What, sir? My voice is breaking. My voice is breaking.
No, ma'am, it's clear for us.
Clear.
What sir is telling? I cannot hear you.
Yes, ma'am. Yes, ma'am. Interrupting since half
Okay,
an hour we
one
are
second.
interrupting. Your voice is interrupting, madam.
1 second, 1 second,
Yeah,
please.
ma'am. No, maybe it may not be problem with you, madam. Maybe there's somewhere else.
Yeah, no, I have changed the headset. Now it will be good. Is it clear now? It must be clear now.
No, yes, ma'am. It's clear.
Okay.
Yes, ma'am. Now it is clear.
Okay, fine. Thank you for the response. Actually, the outside is looks like a white color, but inside it is black color. Carbon column is there. Outside of the carbon column only, they have coated with the calcium carbonate for its stability and for the liquids. And when you want to change the column, then you have to change that entire column. That was the procedure. What is that carbon? They are making the carbon as usual by the carbonization process. And when they are making the carbonization process carbon, that will be little porous. Make use of steam or some of the chemical like sodium hydroxide or sodium carbonate and potassium hydroxide. They will make that carbon porosity or pore surface area little larger. And pore volume and the surface area when it is large, which absorb the particle very faster from any medium. That's what activated carbon is a very good absorbent. When you put it in the water, any coloring substances or any taste substance, anything, any turbid particle which can absorb it and hold it and make it very clear. Like that only in the older water filter system, they have made the column when you pour the water, whatever the turbidity, color and any unwanted things are there, with that pore size, it will be absorbed and hold it. When the pore is completely filled with this kind of particles, then the filter stopped working, then water will come out. That time only we used to change the water filter column. That was the procedure. So the similar kind of thing in the filtration process, wherever if you are using this for color removal, for odor removal, or any pesticides or any organic chemical, whatever you are using for the treatment, if you want to remove, you have to add this activated carbon. When you add that activated carbon, and that will be removed, that activated carbon play a very major role in color removal, really. That's what I told you when I starting increases activated carbon treatment. Whenever the water is coming with the color, then the color is supposed to be removed by activated carbon. I said similar concept. And that suppose that activated carbon when you are using for different process in water treatment, and one particular stage that will become a turbid, correct? One particular stage. That's what the water column I have, filter column I have explained. Once the pore surface area is completely filled up, then there will not be any filtration. If there is no filtration, then the water filter started leaking water, then we'll change the color. Like that situation is coming. That could be also removed by this filtration process effectively. So that is the advantage of filtration process. Clear? And because of all these characteristics, I told you which removes the turbidity, suspended matter, pathogenic microorganism which cannot be removed by the chlorination process, and the chemical treatment when whatever the coagulation, coagulation, softening process when we are doing all those leftover chemicals. And fourth one, I told you that which is enhancing the efficiency of the disinfection process. And last one, I told you when you are doing the color paste and aesthetic pest, any chemical removal, when compare all this effectiveness, impact of this filtration media in water treatment, then they have decided what is the name of the process of filtration. Is it a mechanical process? No. Is it only physical process? It is a physical process, not only physical process. Is it a chemical process? Because it is interacting with the substances. Whenever the interaction is coming between the two substances, then we can assume that or we can conclude that that is a chemical process. And this is removing and making the substances inactive like ozone or ultraviolet radiation. So it is a biological process also. That's what finally they have decided. Filtration is not a mechanical process. It is physical, chemical, and biological process. Got it?
Yes, ma'am.
It is wonderful. Okay. So now anybody will asking about the filtration process, you can write all this. Then what is the limitation of filtration process? I will explain little later. So now you understood what is the use of, what is the importance or the application of filtration process. Now we'll talk. There is a number of story, but they have given very limited information in your book about the filtration process. But anyhow, we'll discuss. Okay. Okay. Now, if you have any doubt about the filtration process, you can ask me before I start talk. No doubt means we can jump. Okay. So now, what are the water treatment process? They have simplified, given a simplified diagram in your book, but it is not correct. They have given raw water, then coagulants, flagellants, sedimentation, filtration, disinfection, storage, and before that screening will be there, plain sedimentation will be there. Those things they have not introduced. Okay, leave it, no problem at all. And why we have to do this filtration process? I have already explained about the importance of filtration. Why we have to do this filtration process? Little fast. To reduce the turbidity, to control the microorganism,
Dependent particles.
to remove the, yes, then those are all need. If you want to do,
remove
then
that.
you must have this. Then from the coagulation, flagellation process, whatever the chemicals left over, either in the soluble form or insoluble form, or after forming the flag also some small particles will be there, that also could be removed. So these are all the need of, then anything else we can, which is many. The filtration we are telling, simply we are pouring the water which is coming, that is training. The filtration process is not that much simple, which involved with many things and which is incorporated with many process. And the particles when you are removing, sedimentation process, sedimentation within the filter bed or within the column, interception and diffusion, absorption and initial impaction. These are all the other factors which incorporate with the physical filtration process. And the biological activity, this is important because one more thing I would like and I wanted to say, that is not in your syllabus. Even I have included, somebody has removed. Now, sewage water treatment people are doing throughout the world. All state government is doing on in all the big city, everywhere sewage treatment is there. How they are doing? They are doing this kind of all process screening, then sedimentation, then coagulation, then filtration, everywhere is there. Only the problem of sewage is when compared to other wastewater, if you take the fresh water, the pathogenic organism is less. If you take the industrial wastewater, the pathogenic organisms are less. But when you take the sewage water, there will be plenty of or enormous quantity of pathogenic microorganisms are there. So whatever the treatment technology we are introducing for sewage treatment is quite difficult. Why? Because human excreta, human waste is also in that. From human waste or human excreta, one time from the human excreta, around 30,000 different types of microbes are there. You just imagine 30,000 different types of microbes are coming out. So hereafter, you be careful to maintain your washrooms. So how many population? How much it is the population? How much wastewater will come? How much pathogens are complex microorganism will be there? Then based on that, they have to decide the treatment technology. So earlier days, they have used, after coagulation, they have used some of the ozone in the treatment or acidic treatment with oxidative things. Then they have do color removal, this, that and all. At last, that water they have used for pisciculture. Pisciculture means aquaculture, fish cultivation here and there. Or sometimes people have used it for agriculture purpose. That was the status. Now, the past 15-20 years, they have introduced microfill filters. What is the use of it? All waste, including human waste or agriculture waste. Sorry, organic waste. Sorry, I have flooded out wrongly. It is organic waste. All these organic waste are highly decomposable in nature. So what they are doing in the biofilter digestion system, they have the filter inside. In the filter, they are throwing the microorganism. The filter will be behaving like a normal filter, but the microorganism will be fitted with that. And the culture the people are making continuously for make it alive. The wastewater when goes through the filter, whatever the organic matters are there, when it passes through the filter, it will be completely decomposed. So decomposed into some manageable form. Further, there will not be any accessible organic matter will be there for any microbes. So the growth of other unwanted microbes will be stopped. That is the method nowadays, including Hyderabad, people are following for treatment of this sewage wastewater. Is it clear? People are sleeping, I think so.
Clear, ma'am.
It is very, very important information whether it is not being included in the, yeah, it is very understanding, and also you can incorporate in the exam also. Okay. So these are all the factors. What are the factors? I said inertial impaction, absorption, diffusion, interception, sedimentation. Along with that, the very first one is training. These are all the different processes are involved in filtration process. About that, we will see now, one by one. What is the theory involved behind the filtration process? Because as I told you that this is a physical, chemical and a biological process. And at one place, if we want to perform all these process, physical, chemical, biological, it is quite difficult. Because physical means we know that pressure will come, temperature will come, flow will come. Chemical means we know that there will be the interaction between one substance to another substance. Biological mechanism means we all got all living things will be there. All these three incorporate on one place means it is quite difficult. Only the substances which we are using in filtration media can proceed all these three processes. That is only the wonder of this filtration process. What are the process incorporate with that? Whatever I told you, those things, and we will I will explain one by one very clearly. About this training, I told you, whenever the particle size is bigger than the whole size of perforation, that will be clogged, and whatever the smaller size, it will be running away. So during the coagulation, flagellation, and frequently remove that upper size particles which are all coming out of the process from the flagellation or clarification, then the coarse particle, whatever will be there, it will be removed, and fine colloidal particle. That means the size of the particle is less than the micron size, 10 to the power minus 6 to 10 to the power angstrom, 10 to the power minus 10 cannot be removed, and they will be it is very smaller than the pore size, so it will be strained out. Such a things incorporate. So what they have to do now in a tea strainer, if you have 2-3 straining layer also, the straining layer at the top it will be bigger and the bottom is goes with the size will be smaller. And they are using the same sort of material, steel or plastic or polymer. But when you are making the sand filter, you cannot use in such a way. When they are selecting the straining process concept in filtration media, and the particle size at the top supposed to be, the pore size at the top supposed to be bigger, and slowly the pore size supposed to be gradually reduced. When you are making in such a system, you have to make select a substance in such a way they have the porosity in descending order. Like that, substances or the pore media they have selected to carry out the staining process, initial stage of filtration process in water treatment system. It is not in tea staining, in the water treatment system. And the second one is Sedimentation. What is sedimentation occur here? You are passing something to the sand bed. That is sand bed only. This is a sand will be there. The sand will be compacted with some other substances. We can say it is we can say adhesive kind of thing, but not exactly adhesive. When you may combine with all these things, then the bed will be very compact and tight. It's supposed to be compact and tight. Now, when the water is coming from the flagellation or clarification process, whatever the small particles will be there, it's supposed to be sedimented on the top surface of the filtration. Clear? And the particle will be any metal oxide which is coming out from the coagulation process. That is supposed to be distributed uniformly on the filtration process. That is the wonder of making the filtration media, because it will be sedimented, that is, but the sedimentation should be uniformly on the filtration process. That is sedimentation within the filter bed. If it is not uniform, immediately the filtration bed will be spoiled. So what they have to make the deposition or the sedimentation of such a particle from the previous stage of treatment supposed to be uniform, then which reduce the damage of filter bed as early as possible, which prolong the life of filter media. That is another thing incorporated with it. These are all things they have to keep it in mind while they are making the filtration bed. And another one is interception. What is the meaning of interception? Common meaning of interception. Anyone please? Intersect and interception means what?
Coming into contact.
Yeah, coming in contact means that may be the common things between two things. That is called the intersection, correct? That is correct only. Common contact, that is correct. Now the water is coming from the clarification process. Why we are doing the filtration? Because all particle may not be removed by clarification. So what we wanted to filter, that particle immediately come in very close contact with the filter media. So the filter media means I did not say only sand. I said many. It is a sand particle of different size with a spherical in nature, and the quartz content must be more than 900. The stability, thermal stability, and uniformity. There are many tests always. When you select the sand material, there will be a 10-15 tests you have to undergo: density, stability, thermal stability, acid was, and you have to wash with the sulfuric acid. The weight should not be changed. Many things are there. The void should be less. There should not be any organic matter attached with the particle. Many things are there. After you are collecting all this, then you are making the bed. That bed is supposed to be combined with many heterogeneous material. And now the water is coming from the flagellation or clarification process. Those particles must be very close contact with the grain material. There will be a reaction or there will not be any reaction? Tell me, there will be a reaction or there will not be any reaction now? There will not be any reaction, correct? Because I told you the filtered media is supposed to be inert in nature. You please follow me, then it is easy for you. Now the particles are coming from the clarification process. There will be an intimate or very close contact with the bed grains, but even then there will be a very small time to be attached with the grains on the pores. But whatever the forthcoming particle, they will be removing the particle from the pore, and but in meanwhile they are very intimate contact with the surface. And whenever the intimate contact is there, the collider particles, they do not settle, but it deviates slightly from the surface of the forthcoming streamline. So the pore geometry will behave like continuous media. There will be a continuous interaction between the forthcoming particle and the grains, coming, staying, and releasing. Coming, staying, and releasing. Coming, staying, releasing. when it is coming and staying in the pore size and releasing, in this trajectory will be going on clearly. There will not be any interparticle interaction between the forthcoming particle and already reached particle. In such a way, they are providing the porosity in the bed to provide the residential time or contact time very less in the bed. That is the point. Again, I will tell you. First, the particles are coming in contact with the bed material. There will be a very close and intimate contact. So you should know that whatever the particles are coming out of clarification should be, this could be the size. It may not be bigger than that. So that before that, you have to remove the bigger size particle from the earlier stage process. So from the clarification, whatever the particles are coming, there must be the size restriction. Bigger than that size particle, you should be removed from either the normal or plain sedimentation or screening process. Clear? So now when the particles are coming and intimate contact with the grain in the bed, it will come and stay. And again, the particles will come. Before it go and stay, the previous particle will be removed. What is the use of it? What is the use of it? Can you tell me what is the use of it doing such a process? I have explained nicely, I hope. The liquid is coming with the particular concentration with particular particle size. Already you have the bed with particular porosity. The coming particle and the bed material both are very close contact with each other. But that particle cannot stay there for quite a long time because continuously the particles are coming from the clarifier. But what is happening? The forthcoming continuously coming particle and the staying particle, they are not interacting between each other. Coming and leaving, there will not be interaction between the coming and already reached particle. So what can be done in such a way? What is there? What is that? That is called interception. There will be an intimate contact with the bed material. There will not be contact between the reactive material. Understood? Such a process is continued till the volume is getting over. Because of that, what is happening? Whatever the particles are bigger than the porosity will be rejected or it is going out. Whatever the particles are smaller than or the same size of pore size will be accumulated on the bed. So in such a way, the particles are smaller size particle could be removed in this. Is it clear now?
Yes, ma'am.
Not clear means tell me, I'll explain.
Clear, ma'am.
Okay. Then diffusion. Diffusion means which is, it is actually the diffusion process applied here for removing extremely very small size particle. Very small size particle when they are intimate contact with the filter grains. And especially for this purpose, people are using slow sand filter because of low velocity and allow for quite a long time. They are removing the very small or minute particle from this. Here only whatever the microbes which is shielded with organic matter could be removed. So that is the use of this diffusion concept. So each and every concept they have covered with a particular purpose. On the whole, the filtration system is working to achieve 90 to 95% free from many of the pathogen and other things from the water treatment. That's what filtration process is very important. And for the filtration, people are spending enough money for packing and backwashing and refilling. It is a very big phenomena, and also sequentially and systematically people are following not only for water treatment, even in many industries people are doing such a things. And the next one is absorption. What is meant by absorption? Any one of you can tell what is meant by absorption? Absorption means what and adsorption means what? Hello? Absorption means what and adsorption means what? Adsorption is a surface phenomena. Absorption is inside phenomena. Adsorption which will absorb on the space surface and it will be going out. Absorption means which hold the material inside. That is absorption. Hello, meeting is over. Hello,
We are
Yes.
there, ma'am.
meeting is over. How many minutes is over? How many minutes is left over?
Ma'am, I think it was supposed to end by 1:15, 1 o'clock or so.
No, ma'am, at 1:30 the class, I know that. It is
Oh.
already 1:30. So, okay, ma'am, we'll wind up, we'll start at 2 o'clock. That is on air pollution and control technology, or you want me to continue the same, we'll continue also. It depends on you people.
Air
You come
pollution,
up with it.
you will
What,
only.
ma'am?
Your air pollution is also dealt by you only, ma'am.
Okay, you come and join at 2 o'clock, we'll discuss, we'll continue this or we'll continue.
Okay, ma'am.
Okay, fine.
Thank you.
Thank you, ma'am. Thank you very much. Thank you.